There's a whole new wave of vehicle suspensions coming your way. Chrysler engineers constantly improve the drivability features and comfort of our vehicles. And two of their versions of the ultimate wave are new for 1990. One is the air spring suspension, optionally available on the wide-body Imperial models. It's a suspension leveling system, a system without any conventional metal spring. And the other new system? It's a variable damping suspension system available on G-body Daytona Shelby and J-body Lebaron GTC models. A choice of three distinctively different rides to meet the mood is just around the corner. And because your customers are riding on a whole new wave of vehicle suspensions, you'll need to familiarize yourself with this new engineering. Follow along, and we'll show you how to ride that wave. In the first segment of today's presentation, we'll discuss the variable damping suspension. Then we'll move on to the load-leveling air spring suspension system. Here's the driver's control center for the variable damping suspension. It allows the driver to select a firm ride for spirited driving on twisty roads and a soft ride for highway cruising. He can also choose the normal setting for a compromise between the other two. This suspension system controls only the ride of the vehicle. It doesn't control vehicle height. Other than pushing the control console button, there's no other effort required on the part of the driver. But there's a whole lot going on inside those shocks and struts. If you remember your basic suspension system theory, you'll know that shock and strut damping rates are determined by internal orifices, which provide varying amounts of resistance to the fluid flow. Large internal orifices don't offer much resistance to fluid flow, permitting the piston to travel the length of its bore more quickly. This provides a soft ride setting. Small internal orifices slow down the flow of the fluid and create a resistance to the piston's movement in the bore. This provides firm damping. The variable damping suspension system provides both types of damping plus a compromise between the two. It's really like having three sets of shocks and struts in one. When a ride setting is selected, an electric motor mounted inside each shock and strut turns a shutter valve assembly. If the soft or normal ride setting is selected, the motor opens up orifices for fluid to travel through. One side for the compression stroke, one for the rebound. When the firm position is selected, the motor closes off both orifices in the shutter valve assembly. I'll explain why in a moment. As the piston travels down in its bore, fluid travels up the hollow center of the piston post here to the shutter valve assembly you see here on this cutaway model. If the soft ride setting has been selected, as the shock is being compressed, the fluid flows up the piston post and, for the most part, bypasses the piston valve. Fluid reaches and travels out the large shutter valve orifices down inside the piston post and out the compression bypass orifice. During rebound, when the shock is extending, fluid flows in the opposite direction through the rebound bypass orifice, which is a port to allow fluid to flow in the opposite direction. When fluid is flowing in this direction, the shutter valve orifices also restrict the fluid flow in the same manner. The check valve determines which bypass orifice to allow fluid to flow through. And normal setting orifices in the shutter valve assembly are slightly smaller than the soft setting orifices to slow down the fluid flow. In the firm setting, the shutter valve completely closes the bypass assembly. The suspension always allows fluid to pass through the conventional piston valve orifices, even though it's virtually bypassed when the soft setting orifice is open. But when both sets of orifices in the shutter valve are closed off, the increased resistance to piston movement caused by damming up the fluid provides a firmer ride. The appropriate bypass valve in the variable damping suspension is selected by the control switch, which sends signals to the variable damping control module, or VDCM, which we'll cover in a moment. The VDCM then activates the internal motor in each shock and strut. This motor opens the bypass valve inside the shocks and struts to achieve the different damping settings. Inside each shock and strut, the motor's position is monitored by a soft position feedback switch, or PFS, and a firm PFS. These switches send position information back to the VDCM. Now, there are three possible correct positions the switches can be in. Soft, firm, and normal are selected by the driver. A fourth and incorrect position is called an illegal position. It occurs when one of the motors drift out of sync. If there is no short circuit to ground or internal motor short since the last time the ignition key was turned off and then on, the control module drives any motors which have drifted back into sync. Position feedback switch input is correct when the PFS signals correspond with the selector switch on the center console. If 2 seconds pass and the shocks or struts aren't adjusted to the correct position, the control module enters the fault mode. The VDCM monitors and controls the variable damping system. It's mounted to a bracket on the driver's side of the trunk. The VDCM also uses a standalone diagnostic system with a connector mounted in the trunk. The entire variable damping system is grounded at the left rear quarter panel inside the trunk area. On Daytona models, the control module is mounted behind the driver's side trim panel under the rear quarter window. The control module has a single 25-way system connector and receives power from the battery through the ignition switch. It's told by the two selector switches which ride mode has been selected by the driver. The VDCM also controls the ride setting indicator LEDs on the switch bezel in the center console. It dims the LEDs when the headlights are on and brightens them when the headlights are off. The VDCM also uses the LEDs to inform the driver if a fault occurs in the system. The VDCM resets whenever the ignition is turned on from the off position. When it's reset, it clears its memory of any faults, reads the selector switch input to determine which ride the driver has selected, and then attempts to drive the motors inside the shocks and struts to the selected position if they aren't already there. The VDCM can also be reset two additional ways. The technician can ground the diagnostic input pin on the VDCM. That's pin number 13 for 3 seconds, which allows the voltage to return to its normal 5 volts. Or the VDCM can be reset by exiting the DRB2 variable damping suspension diagnostic routine. During normal operation, the driver selects the ride position setting, say soft for example. The variable damping control module then moves into action and senses that the soft selector switch is grounded, lights the soft LED light on the bezel, checks the settings of each shock and strut through the position feedback switches, drives the motor inside each shock and strut to its correct position, keeps the LED lit when each corner reaches the selected position, and monitors selector switch inputs and position feedback switch inputs for changes. If there's a failure in the system, the norm LED flashes for about 1 minute and then goes out. It's then that the system enters the fault mode. When the system registers the fault, the vehicle is still safe to drive. There's no need to worry. Remember that in addition to the firm, soft, and normal ride settings, a fourth illegal setting indicates when one or more of the shocks and struts are not located in the selected setting. As we said before, when the system is in the fault mode, the control module turns off whichever LED was lit and flashes the normal or default LED setting. It then tries to drive any motor not in the default position to that position. Remember, on this system, that's the normal setting. During the fault mode, if the driver pushes one of the selector buttons, the LED for that setting won't light. Instead, the normal setting LED flashes for 1 minute and all the LEDs go out. During fault mode, the module will only drive the shock and strut motors to the normal position. This is to safeguard against premature motor failure. All changes made by the driver are locked out until the key is turned off and then on again, which, as you'll remember, resets the module. However, changes aren't locked out during the diagnostic mode. We'll cover that in a moment. An overcurrent shutdown can occur if there's a short circuit in the motor or a short to ground in the body wiring harness. If the VDCM detects any overcurrent conditions, it activates the overcurrent shutdown mode. There are 3 differences between the usual fault mode and overcurrent shutdown. During overcurrent shutdown conditions, the VDCM immediately stops driving all internal motors, won't attempt to drive the internal motors to the default position, and won't allow the normal LED to flash. Additionally, any changes selected by the driver are locked out until the next module reset. Remember, a reset is performed during a key-off, key-on maneuver. Now let's take a look at diagnostics. After the system detects a fault, the diagnostic routine can be accessed by plugging the DRB2 into the diagnostic connector, which you'll remember is next to the control module in the trunk on J-bodies and under the scuff plate in the cargo area of G-bodies. You need to know that the DRB2 can only detect faults for the setting that the damping system is currently in. To test the system properly, you have to use the driver's selector switch on the console to move the system into each of the 3 positions. When you change the selector switch to a new position during diagnostics, the system will try to go to the new position and reports faults only for the new position. You'll remember that system changes are usually locked out when a fault code is entered. This doesn't apply to diagnostic procedures. That's when the system will attempt to make changes and clears any previous faults. Only faults with the current damping selection are reported. If one corner of the car is stuck in the position that's already selected, say soft, it won't be reported as a fault. The DRB2 only shows you failures for the current settings. If the VDCM detects an overcurrent condition in one of the shocks or struts, which may be a short circuit in the motor or wiring harness, it will report which shocks or struts have experienced the overcurrent. You'll have to repair any overcurrent conditions and reset the VDCM before the module can diagnose anything else in the system. Obviously, this means that the overcurrent shutdown takes precedence over any other normal diagnostic routine. With the overcurrent condition out of the way, you can then proceed to normal diagnostics. You can also use a digital voltmeter-ohmmeter to determine which corner of the vehicle is not in the selected position. Be sure to check the forthcoming manual for more DRB2 diagnostic procedures on the variable damping suspension system. Now that we've ridden that wave, let's move on to the air suspension system.